In this video we have two trigonometric integrals to evaluate. So let's look at the first one. We have tangent to the fourth and secant squared. We know the derivative of tangent is secant squared. So I'm going to use the u substitution, let u equal to tangent of x. So the differential here, du, would equal to the derivative of tangent, which is secant squared of x, and then it's dx. And this should be enough to transform the integral to one involving the variable u. So for the first part here of the integrand, tangent to the fourth, and then u is tangent. We'll say the integral of, so in place of tangent we have u, and that's to the fourth power, and then secant squared of x dx, right here, secant squared of x dx, that's du. So now it's just a simple integration, power rule for integrals with respect to u. So we add 1 to the 4, we get a 5. Divide by 5, we can make this a 1/5, or I could put it over 5, plus the constant of integration. And then always go back to the original variable. So u is tangent of x. I put tangent. I could put the whole thing in parentheses, so I could just put the fifth power here. That's over 5, plus the constant of integration. And then a quick check here. Take the derivative of this, and we should get the integrand. So derivative of this, be 5 out in front, cancels the 5. And then you subtract 1 from the 5, you get a 4. So that gives me the first part here of the integrand, tangent to the fourth of x. But then using the chain rule, you take the derivative of tangent, gives me secant squared. That checks out. Now the second one, again, if you don't see what method to apply right away, look for a u substitution, like the first one. And that's what this is going to be, because if I let u equal to secant of x minus 1, so here I let u equal to the expression in the denominator. Sometimes it's going to be an expression under a radical or a radicand, and sometimes it'll just be something taken to a power like in the first one. And then we say, okay, du equals to derivative secant is secant of x times tangent of x, and then that's dx. And then from there you say, okay, let's transform this. For the secant of x minus 1, that's of course your u. And for secant x times tangent of x dx, right here, that's du. So I can just say this is equal to du over u. And of course that's going to be the integral. The integral of secant of x, tangent of x, dx, that can be replaced by du. And in the denominator, secant of x minus 1, that's du. So then this is equal to the integral of anything in the form du over u is natural log of absolute u. And now I'm taking the integral, so I don't need this. So natural log of absolute u plus the constant of integration. And then we just go back to the original variable, ln of secant of x minus 1 plus c. Final answer. And see if you can take the derivative of this and show that you get the integrand. Just doing a little bit of trigonometry with a simplification, and of course using the formula for the derivative of ln of u. Thanks for watching. We'll see you next time.